Hi, welcome to our channel Siri Max class. Today in this number system chapter, I will explain two topics, square and perfect square. Okay, first of all we can learn about square. What is a square? The square is a number, it is the product of itself. The square is a number. What is the number? For suppose here I can take the number 2. The product is itself also. Here we can multiply the same number with 2 times. 2 2s are 4. Okay, 2 into 2, here I can write 2 power 2, 2 square. Okay, 2 power 2. Here how many times here we are multiplying? 2 times. So here 2 power 2, here we can write. In this is we can read as 2 square. 2 to the power of 2, simply we can call as 2 square. Okay, once again see here what is the square? Square is a number, the product of the same number multiplying 2 times is called as square. Okay, for suppose here we can take another number. For suppose here I am taking the number 5. What is the square? Square is nothing but product of the same number with 2 times. So simply we can write as 5 to the power of 2, simply we can call as 5 square. Any number to the power 2 is called as square. Okay, same number here we can multiplying 2 times, we can write as power 2. This is simply called as square. Okay, 5 square, 2 square, any number we can multiplying 2 times, we can write as power 2. This is called as square. Okay, we go to the next topic, perfect square. Okay, what is a perfect square? A natural number is called as a perfect square if it is the square of any natural number. Okay, see here one example. Okay, for suppose here I am taking the number 36. Okay, it we can write as prime factorization. Okay, 36 we can write as prime factors. Prime factor means we can write as LCM. Okay, how many times? 18 times. Okay, 2 table 9 times. Okay, third table 3 times. Okay, here we can write as 36 as 2 into 2 into 3 into 3. Okay, in the before topic we already know na 2 into 2. Same number we can product 2 times, simply we can write as power 2. Into here also this number also we can write as 3 square. 2 square into 3 square. Okay, what is the number here we are taking? We can write as same number square. This is called as perfect square. Okay, once again I am telling you, don't confuse here. What is the perfect square? A natural number is called as a perfect square when the condition is we can write as the number product of two numbers and we can write as same as power 2. In these numbers are called as perfect square numbers. Okay, for suppose here I am taking one more example to you. Okay, for suppose here I am taking the number 28. Okay, here we can write the prime factors. 2 14s are 28 and 2 7s are 14. Okay, see 28 here we can write as 2 into 7. See here 2 into 2. Same product na, so here we can write as 2 square into 7. This is a perfect square? No, this is not a perfect square. Why? Because here only one product we can write as square, but here 7 is only single one. For suppose here another 7 is there, this is a perfect number. Okay, here what I am saying, you know everything. 28 here we can write as 2 into 7. Okay, here 2 2s are there na, so we can write as 2 square into only one 7 is there. So this is the single number na. So that's why this is not a perfect square. Okay, 36 we can write as 2 square into 3 square. That's why here we can write both are same squares. That's why this number is called as perfect square. Okay, next we go to the properties of a perfect square. Okay, now we can learn properties of a perfect square. Okay, already we know na perfect square, any number we can write any natural number to the power 2 without leaving any number. That numbers are called as perfect square numbers. Okay, some properties are there to identify which number is perfect number and which number is not perfect number. Here some conditions are there. Now we can learn about the properties. What is the first condition or first property? The number ending with 2, 3, 7 or 8, these numbers are not a perfect square. Not a perfect square. Okay, see here the numbers ending with, for suppose 92. Here the number ending with 2, this is not a perfect square. And here I can write 393. See here the number ending with 3, this is not a perfect square. And also 147. Here the ending means unit digit plus 7 is there. No, this is not a perfect square. And also here also unit digit plus is 8. Okay, see here the number ending with 2, 3, 7 or 8, these are the ending numbers. That is not a perfect square. We can simply identify. Okay, see here what is the unit digit plus 2 is there na, so this is not a perfect square. 3 is there na, so this is also not a perfect square. We can see and easily observe that. 7, 8, whenever the unit digit plus 2, 3, 7, 8 are there, that numbers are not a perfect square. This is the first condition. We go to the second condition. Okay, what is the second condition? The number ending with the odd number of zeros is never a perfect square. Odd number of zeros. Odd number of zeros means 0, 3 zeros and 5 zeros. The number ending with these odd number of zeros is never a perfect square. Okay, see here. Okay, see here odd number of zeros. Already we know odd numbers 1, 3, 5, 7, 9. So many. These odd number of zeros are there in a number. This is never a perfect square number. Okay. We go to third condition. The square of a even number is always even number. Square of even number. Already we know even numbers. For suppose here I can write 2 square. 2 square equal to 4. This is a even number. Okay, see here one more even number here we can take. For suppose 8 square here. 8 square is nothing but 8 into 8. 8 8s are 64. Okay, the square of even number is always even number. Here square of a number, we get the answer also even number. This is the third condition. Next, fourth condition. The square of odd number is always odd number. Okay, here we can check 3 is odd number na. So here we can take square. 3 square. 3 square is nothing but 3 into 3. 3 3s are 9. Okay, see here 3 is odd number. The square of odd number, we get the answer also odd number. Okay, one more example here I can take. 7 square. 7 square is nothing but 7 into 7. 7 7s are 49. Okay, see here 7 is odd number na. The square of odd number, we get the answer also odd number. Okay, we go to the next condition. The square of a proper fraction is always smaller than the given fraction. What is proper fraction? For suppose here I can take 1 by 2. The square of proper fraction is always smaller than the given fraction. Okay, 1 by 2 is the proper fraction. Here we can apply the square. The square of a proper fraction is always smaller than to the given fraction. So here what we observe here, 1 by 2 is greater than the 1 by 2 square. For suppose here I am taking 1 by 4. 1 by 4 is always greater than the square of 1 by 4. Here everyone understand what I am saying? The square of a proper fraction is always smaller than the given fraction. Okay, we go to next condition. The difference of square of any two consecutive natural numbers is their sum. Okay, what I am saying here, the difference of square of any two consecutive natural numbers. Okay, for suppose here I am taking 5 and 4. These two are consecutive natural numbers now. Okay, what we are saying, the difference of square of these two consecutive numbers. Difference means minus na. The difference between square of any two natural numbers is their sum. Okay, see here, what is the 5 square value? 5 square value is 25. What is the 4 square value? 4 square value is 16. Okay, what we get the answer? 25 minus 16, how much? 9. Okay, see here, in this condition what they are saying, the difference of square of any two consecutive natural numbers is their sum. The numbers sum. What are the numbers? 5 and 4 are numbers now. So 5 plus 4 equal to 9. Okay, in this condition what they are saying, the difference of square of any two consecutive natural numbers is the sum of the two given natural numbers. Okay, one more example here we can take, you will easily understand. Okay, 7 and 6. These two are consecutive numbers now. What is the condition? Difference between squares of these two numbers. Okay, what is its sum? So 7 plus 6. 7 plus 6 how much? 13. Okay, this is one more property. Okay, we go to the last property. Next, 7th property, 7th condition. What is the condition? The sum of the first n odd natural numbers is a perfect square. Okay, what here I am saying? The sum of the first n odd natural numbers is always a perfect square. Okay, tell me what are the first odd numbers? 1 plus 3 plus 5 plus 7 plus and so on. So many values are there na. Here I am taking 1, 2, 3, 4 values na. Adding these values, 3 plus 1, 4, 4 plus 5, 9, 9 plus 7 how much? 16. 16 we can write as 4 into 4 na. That is nothing but 4 square. This is also a perfect square. Here we can take number of odd numbers. First n odd numbers, the numbers is a perfect square. Okay, what is the condition? The sum of the first n odd natural numbers is a perfect square number. Okay, thank you so much.